This conference will now be recorded.
So today let us go with one more new topic and very important one, that is microservices. So just a divide and work concept is only microservices. So what is this microservices is? Microservices is used to create, is used to break up single large monolithic system. Single large monolithic system into multiple independent components. What is this microservices? It is used to break up the single large monolithic system into multiple independent components. Right? So what is monolithic system? Up to now, whatever the projects we have done, all are monolithic. So in the olden days, if you take one project, complete project is developed only using one technology. Only using what? One technology. Like if you take the banking applications like ICICI, or if you go with this one like Access Bank, these are all monolithic. But coming to this one like Amazon, they are done with microservices. Because in Amazon we go with the different components, like for example, searching for the cart, then done by one language, one programming language. Filtering part is done by one more programming language. The payment process is done by one more programming language, like that. So only one project, but we use different languages. We use what? Different languages to make that project. In the olden days, one website means only one language. One web application means only one language, and we connect only to one, we deploy into only one server and only one database. But nowadays, most of the projects are with microservices. Only one web application, but we use different languages for that web application. Search operation we do by using Python is good for search operation. Okay, database connectivity, all those things are good by using Java technology, like that. Security features are taken care by .NET. So we use different languages to make up a single larger system. Such type of things we do by using microservices. You can say microservices is used to break up single large monolithic system into multiple independent components. Okay, let me elaborate more on monolithic. In monolithic application, all functionalities are part of single program running in a single environment. In monolithic application, all functionalities are part of what? A single program running in a single environment. Okay, now let me elaborate using a diagram. Monolithic application. Up to now, whatever the projects we have done, they are all monolithic only. Let me open this. When you take this monolithic application, in server we deploy, like example, if you take a shopping application, where we go with the different components like buyer profile, catalog management, cart management, all functionalities are part of what? Single application. Means we create only one web project and we deploy only in one server and we connect only to one database. Okay, and from client, either it may be web or mobile, we can connect to the application. Now, coming to microservices. In microservices architecture, the components are built and deployed. The components are built and deployed independently. The components are built and deployed independently. Again, finally, we have to integrate. To integrate into a single larger system. Integrate into what? A single larger system. Okay. So this integration is the major part of this microservices. Let me elaborate using a diagram. Microservices architecture. So when you take this microservices, when you go for microservices, here we go with the different components like buyer profile. Buyer profile is created like a microservice in using Java technology and deployed in Tomcat server and connecting to Oracle database. Catalog management, it is created like a microservice using .NET technology, deployed in IIS server, connected to SQL Server database. Cart management, created like a microservice using PHP technology, deployed in WAMP server and connected to MySQL database. From client, based on the API gateway, based on the REST API, it will connect to the respective components here. It will integrate to the respective microservice. So finally, these components should interact with each other. So when one component want to connect to other component, the integration part is the major concept of this microservices. Who is going to take care of the integration part? That's a main concept to discuss over here, right? So just a divide and work concept only, microservice. But whenever you go with a web application, in the olden days, a web application is developed only using single programming language. But nowadays, only one web application, we are using different programming languages to develop that application. Okay, so that concept only microservices. Now, how the integration is done, let us understand. For this, the integration part we do by using Netflix Eureka server. This is the major thing what you have to remember. Netflix Eureka server. Netflix Eureka server is used for building the service registry server. Is used for what? Building the service registry server, and Eureka clients which will register themselves and discover other services to call REST APIs. In order to call the REST APIs, they register with Eureka server. So if someone asks you how you developed microservices means, the answer what you can say by using Netflix Eureka server. Now, let us understand more in depth of this. Now, if you consider, let us suppose we have created one microservice. Simple microservice means you can consider like a Spring Boot application. We have created one Spring Boot project here. So like let me go with student microservice. What this student microservice is going to do is it's going to accept the school name. It is going to accept the school name. Based on the school name, we want to return the list of students of that school. What are the school name we have given? Based on that school, we want to return the list of students of that school. Now let us suppose this student microservice is deployed in Tomcat server. running in port number 1111. Let us suppose running in port number 1111. Now, let us consider we are having one more microservice, school microservice. School microservice, where this school microservice is going to accept the school name. Once it accepts the school name, to get the list of students of that school, it is going to invoke student service. Means school microservice is going to invoke your student service. Invokes student service. Now, let us suppose this school service is deployed in Tomcat server, running in port number 2222. Right? Now understand carefully. When school service want to invoke student service, do we need to know the location details where the service is running? Yes or no? When school service want to connect to student service, do we need to provide these location details to school service to invoke? Yes, right? Without knowing the location where the service is running, we cannot invoke. We cannot invoke, right? So we should know the location where the service is running, like the address of your server and the port number where it is running. Now let us suppose in future we have changed the location of your server. Like example, this port number we have updated to 3333. Then do we need to give this new port number details to school service again? Yes. So whenever a service changes the location, we need to update to the other services where it has been invoked. Here only 2 services, no problem. But in reality, we may go with the 20 services or hundreds of services. If one service changes the location, we have to update to other services where it has been invoked. So this is the complex part of the developers. Integration is becoming complex over here. So this is the place where we make use of what? Eureka server. So what we have to do? We have to configure Eureka server. We have to configure the Eureka server. Then once we configure Eureka server, whenever we create a new microservice, we have to add that microservice to Eureka server. Adding means we have to register in registry. Register in registry. Whenever we create a new microservice, we have to take that microservice, register in registry. Register means what? We have to update the location details where service is running. We have to just provide the location details where service is running. Register in registry. So like that, what are the microservice we create? We have to register those microservices with Eureka server and registry. Now, when school service want to invoke student service now, when school service want to invoke student service, what we have to do? This school service will connect to Eureka server first. It won't directly invoke now. It is going to connect to Eureka server and it's going to look up for student service. It's going to look up for student service. Look up means what? Getting the location details where service is running. The location of service where it is running. And once it gets the location details, then school service will invoke student service. So when one service want to invoke other service, they won't invoke directly. First of all, it is going to connect to Eureka server, then get the location details where the service is running, then it is going to invoke. So the advantage is in future, if this port number gets updated to 3333, you need not do anything. As a developer, don't do anything. This will automatically get updated to Eureka. Nothing to do, only one time registry. Once we configure server, only one time we have to register with Eureka. After that, you need not do anything. So if our service changes the location, that new details will automatically get updated to Eureka. When school service want to invoke student service, first of all, it is going to look up into Eureka, then it's going to invoke. Okay. So the main integration part between the services is taken care by what? Eureka server. Clear everyone? Any questions? Anyone, any questions? Right? No. So the planning is like this will take totally 2 classes for us to complete this complete application. So what we do today is we'll go with the student microservice today. Day 1 we'll discuss student microservice. Then day 2 we go with the complete picture. Day 2 we'll discuss the complete picture. Means in day 1 we create only student service. Today we go with student service and we check whether it is running properly or not. Then in next class we create school service. Then we invoke student service directly by taking the location details and we'll try to understand the drawbacks. Then we configure Eureka server and we register our services into Eureka server and we look up for student service in Eureka server, then we invoke. So the complete part we do it in day 2. Okay, so today let us go with only student service. Let's start working with the application. Developing a microservice application using Spring Boot. We are going to make use of Spring Boot and Netflix Eureka server. Now, the first step, create a Spring Starter project, student service in STS. Let us open STS, Spring Toolsuite. Then let us choose a workspace here. I'm going with microservices folder, any folder. Now, create a Spring Starter project, file new Spring Starter project. I'm going with the name student service. Type Maven Java version 8. Then group, I'm saying student service. Artifact, it automatically takes the name. Then package form.student.service. Click next. Here it is going to ask you for the project dependencies. So just I'm adding Spring Web. I'm adding Spring Web and click on finish button. Let me document. Click on file, new Spring Starter project. Click next. Spring Starter project in the name, go with student service. Type Maven Java version 8. Group student service. Artifact, the project name student service. Package where you want to store .java files, com.student.service. Click next. In project dependencies, add Spring Web and click finish. That's it, which creates the project for us. Once the project is created, by default, it is going to deploy in Tomcat server. It uses Tomcat server running in port number 8080. Now we want to change the port number. So how to change port number is go to this application.properties file under src main resources folder. Here, change the port number. Server.port equal to 1111. In application.properties file, we are changing the Tomcat server port number. Very simple way to change by using the property server.port equal to the port number what you want to provide. Now, what is our step? Update application.properties file of src slash main slash resources folder of student service to update the Tomcat server port number. Now the next step is let us create a class, create a Java bin class student in com.student.service package of src slash main slash Java folder of student service. Let's create this file. Under src main Java, you can find the package com.student.service. Right click and say new class. Go with the class name student. Go with the properties. Private string the name. Private string class name. Some properties you wish. Go with the constructor. String name, string class name as arguments. This dot name equal to name. This dot class name equal to class name. And when a class contains parameters or constructor, it is always suggested to go with a default constructor, right? Or you can use Lombok annotations also. That I skip it willingly. So you try to go with the Lombok from your end. And one more point, when you are configuring Lombok tool, no, when you run lombok.jar, it is going to ask you the location wherever IDE is present. Once we select that, if your IDE is already opened, we have to close it and reopen. Okay, that I missed out to mention in the last class. So once we configure your Lombok tool for your IDE, if the IDE is already opened, like Eclipse or Spring Tool Suite, close it and reopen, right? Let us go with the next one and very, very important one. This is the major file. Create a REST controller class. Why we have to go with the REST controller? Because whenever you want to access a service from one location to other location, we have to make it distributable. So to go with the distributable, we go with the REST controller. So to create the REST APIs, we go for REST controller. So create a REST controller class, student service controller in com.student.service package. Student service controller. So this is the major important file. Right click on com.student.service package, create a class student service controller. Now write the code. In this, to mark it as a REST controller class, the annotation what we have to use above the class @REST controller. In this class, we go with a property private static map string comma list student school DB. So we are going with a property school DB. What type here? This map type. It's of what type? Map type. And this key is what? String, means the school name. The key is school name. School name is of type string. And one school goes with multiple students. How to manage multiple students? List student. So for one school we'll have multiple students. So we are going with the list student. So key is of type string. Value is of type list student. Now let us go with a static block. Whenever the class gets loaded, it will go to static block first. Now let us allocate memory for school DB. School DB equal to new hash map or anything, a linked hash map or tree map, whatever you want, you can go. New hash map string comma list student. Now let us create a list first. List student list equal to new array list or linked list. Now create a student object, student stud equal to new student. I'm going passing the value, the name and the class. The name and class. And one more point I miswrote. Here we have to even go with setters and getter methods. Okay, I'm just even generating setters and getter methods here. Now here I'm creating student object with the name of the student and class. Now add the student to the list. Student list dot add student. Now create one more student object. Stud equal to new student, the name and class. Now add this student to the list. Student list dot add stud. So we have added two students to the list now. Now go with the school DB. School DB dot put. In map we are having put method which takes two arguments. First one is key, second one is value. Here we go with the key like ABC school and the value student list. We are going with what? ABC school, and to that ABC school we are adding student list, means to this ABC school we have added two students. Now let us go with one more list. Student list equal to new array list. Then now create a student object, the name and the class. Add this student to the list. Create one more student object, the name and class. Add this student to the list. So we have added again two students to the list. Now say school DB dot put. I'm going with the school name XYZ school. To this we are adding again student list. So what we have done in this static block, we have created a school DB and we have added two schools. To the school DB we have added two schools, and every school goes with two students here. Every school goes with two students. So when the class gets loaded, this school DB is ready with values. Now let us create a method, public list student get students, which takes a school name as argument. So to this method, when I pass the school name, based on the school name, you should return the list of students of that particular school. How to get that? Very simple. List student list equal to school db dot get. To the get method, if you pass the school name, so school DB is what? It's a map. In map, we are having get method. To the get method, if you pass the key, it's going to return the value. So school name is the key, value is student list. So what are the list we are getting? Return that. Return that. Now, so to enter into this method, we need to do the mapping. So which annotation is used to do the mapping part? At the rate request mapping. The mapping is get the student details for school. I'm passing the school name. Get student details for school and we are passing the school name. So this school name we are passing along with the path. So how to take this path variable? Which annotation we use for path variable? At the rate path variable. That's it. Okay, so what is the school name you pass? Based on that school name will come and store into the school name. Based on the school name, you are getting the list of students of that particular school, right? So what is the API now? APIs to access student service. This API http://localhost:1111. The port number we have changed it to 1111. Get student details for school. This one request mapping. Get student details for school and we pass the school name. So this school name will come and store into this path variable school name. We are taking that value using path variable annotation. In school DB by using get method, if you pass the school name, it returns the value. That only I'm returning here. Can go with one more. XYZ school. Right? Now, save it. So the code is ready now. Any questions anyone up to here? No. Let us run this project. Run student service as Spring Boot app. Now to run, right click on student service and say run as Spring Boot app. Can see here Tomcat server started. See port number we have modified now 1111. Now open browser and type the URL http://localhost:1111 get student details for given school. So we are going with ABC school. See here it's returning the data for ABC school, the name and the class. The name and class. Now if I go with XYZ school, then it's going to return the list of students for XYZ school. The name and class, the name and class. Okay, so that means my student service is working. So how to run? Right click on student service and say run as Spring Boot app. Open browser and type the following APIs. That's it. So that completes our student service. We have done with what? Only this part. We have created this student service running in Tomcat server port number 1111. Right? So in the next class, what we do? We create school service, which is we deploy in Tomcat server running in port number 2222, and we invoke student service. Then we'll see the drawbacks. What drawbacks we are going to face? We'll see that. Then after that, we configure Eureka server. We register our services into Eureka server. Then after that, this school service will connect to Eureka server to get the student service and it's going to invoke. So the complete picture once again we are going to see in next class. Okay, very important. Don't miss out the next class. That's the major thing to discuss about microservices. Okay, whatever we have done now, up to now, it's a simple Spring Boot web application, simple Spring Boot application now. Okay, so next class only we'll be concentrating on microservices concept by configuring Eureka server. Eureka server is mainly for integration part. Integration part is the major thing of microservices. Right? Any questions, anyone?
Sir,
So
this question
please.
is a bit generic. I was asked
Okay.
in interview in one of the company few months back, and that
Okay.
is the question was, is microservice architecture better than monolithic? The comparison was asked. So can we give that? I was in favor of microservice, given all the advantages which you mentioned, like separate development, separate build, and
Right.
so if we compare, like, microservice is better with compared to
Right.
monolithic always, right? Whether we can
Right.
say that.
Always. Yeah, we can always say that.
Okay. Yeah.
Yeah, because nowadays, if it is a very big project, always go with microservices only. Okay.
Yeah.
If it is
Okay.
very
Okay.
small project, then we go with monolithic. But most of the projects are bigger projects nowadays. Like if you go with any shopping application, if you go with banking applications, almost all bigger projects. In almost all the applications, we are having the payment processes, we are having the search engines. Wherever you are having search, we think of other programming language like Python. Okay, that code is
Yeah. So,
developed
sir,
by.
there was one cross question from the interviewer that in microservice, the disadvantage which he mentioned, that different services are there. So let's say there is a bug in the uh, entire project. So how do we debug, like different applications are having different logs at different places? So how do you find out the bug? So that was the
Yeah,
point which.
finding the bug. Yeah, that is a drawback here. So that logging part should be taken care by some other group of people.
Okay.
Okay,
Okay.
right? Yeah. So don't miss out the next class. Before I close for today, one small note. No class tomorrow. No class tomorrow. That is 8th of August at 7 p.m. AST. So next class, as usual, next class will be on 9th. Right. So in the next class, we complete this. After that, we'll require 3 more classes to complete our course, Angular. Right. Thank you all. Thank you very much.